Okay, welcome to my algorithm that I chose for assignment 1. So the algorithm I chose is called the sieve of Eratosthenes, which is essentially an ancient algorithm used to find prime numbers up to very high numbers. It can go more than 1,000,000. So right away we start here with my encapsulated variables. So I have all of my variables are longs because I needed to be able to deal with large numbers bigger than ints. So I have a limit, then I have an array list, which is called numList, and then I also have a square of limit. And then I have one constructor in my sieve of Eratosthenes class, which takes a limit from the user, which he inputs in sieve runner, right over here. So then it transfers this limit that the user inputs into the encapsulated variable up here. And it also takes the square root of this limit that the user's inputted, because I found that if you take the square root of the limit, you can ensure all prime numbers can be found. And then right away we populate, we call the method populate, which is right down here, and that essentially creates numList, the array. So here's populate, and it's very simple. It essentially starts at the number 2, and then it works its way up to the limit that the user's inputted. So it essentially just creates an array with numbers from 2 up to whatever the limit is. Then we come back up here, and I'll have my accessor methods in case I needed to do a contest problem that for some reason needed to get some of these variables, and since they're encapsulated I need an accessor method. So I have a limit accessor, a numList accessor, and as well as a square of limit accessor. And we go down here to the main part of this class. This is essentially where the algorithm runs. So we have the numList, and essentially you get the list, you call getList the accessor method. And then I have a double array here, or a double for loop. So the first one, it starts at 2 and it works its way up to the square of limit. So essentially how the sieve works, the sieve of Eratosthenes, is that you go from 2 all the way up to the square root of the number of the limit, and then it counts in the array each multiple of this I object. So if it's 2, 4 is a multiple of 2, and then it'll remove each multiple and leave only the prime numbers. And then once all the possible multiples of 2 have been exhausted, it works its way up to 3, and so on and so on. And then in the second loop, in the nested loop, the if statement here essentially says if the object, or if the element inside this array list is less than I, so it's less, or is greater than I, which is the multiple, and the element in this array list is not divisible by I cleanly, that would essentially make it a prime number. And then if it is a prime number, if this if statement is true, it removes that object, or it removes that element from the array list, and then C minus minus, so it reduces this count of C. And then numList.toString, which makes it possible for the user to actually see the array list when it's printed, and then it just returns numList, because as we go back up here, the return type for this method is a long array list. And then we come down here to the print file. So essentially I wanted to print to an actual file because I didn't want to print just to the console. So essentially we have a file object here, and the file is named output.txt. Then we have the file writer object, and it takes file, this file object over here. And then we create a print writer object, and it takes fw, which is the file writer object. And then here's a for loop, and it essentially goes through the array list returned by the method up here. This method find prime, since it returns this array list of long, and then it takes each element and it prints it to the file, and it creates one line per each number. So it can be a really short list if it's a small limit, or a really long list if it's obviously a much bigger limit. And then the file is closed by using pw.close. So if we go over to the sieve runner class, which essentially is the only way for the user to actually run the class sieve of Eratosthenes. So we create a sieve of Eratosthenes object called running, and let's say we set the limit to 10. And then you do running.printFile, which is this method here. And then since it requires an array list of type long, you essentially give it the array list returned from the method up here, find prime. So it'll return a method with only prime numbers. And if we press run here, and we press F5 on assignment 1, the project, and we go to output, it returns all of the prime numbers up to 10. So 2, 3, 5, and 7. So there are two other, examples that we're going to look at. So another one is if the limit is a prime number, let's say 11. So we press play, and then we have to go and we refresh the project, F5, and we go to output.txt, and then it goes 2, 3, it outputs 2, 3, 5, 7, and 11. Usually, when I first started using this, I would only use numbers that were composite numbers, and then when I first ran a prime number, I realized that it didn't go up to, let's say, 11. It only printed 2, 3, 5, and 7, even though 11 was actually a prime number. So essentially, I just figured out that instead of here in the populate, instead of having less than limit 1, which really only works for composite numbers. If the limit is a composite number, you put less than or equal to the limit. And this also works for composite numbers because find prime just removes every single non-prime number. So it works for both prime numbers and composite numbers. So we've chosen the limit to be 10, and then we've chosen the limit to be 11. So what if we put in a really big number, like, let's say 1,000? We press play, and then we refresh the project. And then it prints out all of the prime numbers. And that's essentially my algorithm. It's fairly simple. It grabs a limit from the user in the sieve of Eratosthenes constructor. Then it takes the square root of this limit because as we go down here into the find prime, this for loop here is essentially the counter of the multiples, and it starts at 2, and then it checks every single element in the array list whether or not it's multiple. It's a factor of 2, and if it is removed right here, numList.remove. And then once it's exhausted all possible multiples of 2, it moves on to 3, and then it moves on all the way up to the square root of the limit, because if you go to, let's say, 10, that may work for smaller numbers, but obviously if you pick a humongous number, 10 million, it will obviously not find all the possible prime numbers. And then essentially it populates the array using this populate method that essentially just creates, it starts at 2 because 1 and 0 are not prime numbers, and it creates an array list full of elements from 2 all the way up to the limit 1, including the limit, because in case, let's say, the limit is a prime number, like 11 is a prime number, therefore if you don't do less than or equal to, 11 will not be included in the list. And then after this find prime removes all the prime numbers from the array list, we use this method here, print file, and it essentially just creates a new file called output.txt. And in the sieve runner class, the user can simply create a sieve of Eratosthenes object, give it a limit of their choosing, running.printfile, invoking the method print file, and you give it the array list created by the method findPrime, and they refresh the project, and then they just go to the text file, and here are all the prime numbers. Thank you very much.